Alright, so this is the last review video for the Chapter 6 Quiz 2 review, and now we're going to deal with the ones that have equal signs, remembering that each thing we deal with slightly differently. Complex fractions, we just find the LCD, multiply by the LCD, and simplify. Synthetic division is completely different, but this one, when we have equal signs in them, means we're going to have to solve and find our x values in the end, unlike the other ones where we were just simplifying things. Now, because they're solving equations, we have two options, remember. We can cross multiply to solve, or we can go ahead and find the LCD, and it depends on how many fractions there are. So when we look at this first problem here, there are 3 fractions with an equal sign, so that means there's more than two fractions that equal, remember, means that we have to use an LCD. So if I'm going to use an LCD, that means I need to factor all of my denominators as a first step. Well, there is no GCF here, and there's no exponent, so we leave it x plus 1. Again, no GCF in x plus 4, no exponent, leave it as it is. This one, however, we need to factor, so we can think about this as what multiplies to our last 4 and adds to the middle 5. Well, that would be 1 and 4, so this becomes x plus 1, x plus 4, and we can go ahead and eliminate that piece. There is no denominator on this side, so I don't have to worry about that. So my LCD is x plus 1, x plus 4. However, please, please, please do not forget that you also have to deal with domain, right? When you're solving equations, you have to have domain. So anytime you see an equal sign, you have to do domain, which means setting the denominator equal to 0 and solving, and remembering that that is not an acceptable answer. So x cannot equal -1 in the end. So x plus 4 equals 0, subtract the 4, x equals -4, and again, that's not an acceptable answer. So these two numbers are not acceptable. So when we write our domain, remember, this is what we have to remember, that it means those two numbers are not acceptable, but we have to write it in interval notation. So everything from -infinity to the smallest number, which is -4, is okay. Everything from -4 to our next number, -1, and everything from -1 to positive infinity. So all of the numbers in these ranges are okay, but you cannot have -1 and you cannot have -4. Now that we've clarified that, we can actually go ahead and start solving by multiplying each fraction by the LCD. So we need to bring down our first fraction, 3x over x plus 1, and multiply that by our LCD of x plus 1, x plus 4. Box it in. Make sure you bring down your minus sign, and your next fraction, 13 over x plus 4, and multiply that by your LCD, x plus 1, x plus 4. Box that in. Bring down your plus sign, right, because we've got a plus sign here now. Minus, then a plus. Don't put an equal sign. I know you guys are used to putting an equal sign next, so be careful. So we're doing 9 over x plus 1, x plus 4, and we're multiplying that by our LCD, x plus 1, x plus 4. And we box that one in, and then equals 0, and again, that's another piece, so we have to multiply that by our LCD, x plus 1, x plus 4. Box that in. So, in this first piece, when we look at it, we should recognize that the x minus 1's can cancel, leaving us with 3x and x plus 4. Again, bring down your minus sign. X plus 4's cancel, leaving us with 13. X plus 1. Bring down your plus sign. X plus 1 cancels, x plus 4 cancels, leaving us with 9. Bring down your equal sign. Now, a lot of students get stuck here because they actually start multiplying it out. But isn't 0 times anything just going to give me 0? So we can just leave that 0. Now we need to go ahead and solve this problem, which means we need to start distributing. So 3x times x is 3x squared. 3x times 4 gives me plus 12x. Negative 13 times x is negative 13x. Negative 13 times 1 is negative 13. Bring down our plus 9, still equals 0. Combined our like terms, so we have a 3x squared. 12x minus 13x gives us a minus 1x. Bring down our plus 9 equals 0. Now recognize at this point, since we have an x squared and an x, that means we have to factor, right? Which means it needs to equal 0, which it already does. So now we need to factor this. So we should look for a GCF first. Unfortunately, there's not a GCF here, so this means we're going to have to do guess and check because our first term is a 1. The nice thing about that is Miss Holtz messed up there, so make sure you're careful. There were these like terms that needed to be combined as well. Negative 13 and 9 would combine to give us not 9, but negative 4. So be careful not to miss combining your like terms there. So now we go back to factoring. 3 times 1 are my options for my first one, so we're just gonna go ahead and put a 3x and a 1x because there's absolutely no other options. My options for 4 are 1 and 4 and 2 and 2. So that means we're going to have to do some guessing and checking here. So if I want to get a 1, I'm probably going to guess the ones that are closer. So I'm going to try 2 and 2 first. Well, that gives me 2x, and this would give me 6x, but there's no way for 2 and 6 to combine to give me 1, and switching them wouldn't change anything. So that tells me that although that might have been a good guess to begin with, it did not end up working out. So now we have to guess 1 and 4. Well, I don't want to multiply the 4 by the 3 because that would get me to 12, which is pretty far away. So we'll put the 4 here and the 1 here, giving me 4x and 3x, which would give me a negative 1 if my 4 were negative and my 1 were positive. And we check the last, negative 4 times positive 1. Would not give me a positive 4, but that's okay because, again, realize that negative 13 and positive 9 actually give us negative 4. So this one actually did work, but again, be careful with combining your like terms. And I can erase the checking step so we have space to actually solve this. So 3x minus 4 equals 0, x plus 1 equals 0, and then we solve by adding 4. So 3x equals 4, divide by 3, x equals 4/3, subtract 1, x equals negative 1. So now we need to check our domain and make sure that all of that is okay. Well, 4/3. Well, we just said x couldn't equal negative 1 or 4, so this one's fine. But negative 1 we said is not acceptable, so we would need to cancel this out because of the domain. Domain says this is not allowed because it would make the denominator 0. So my final answer is just the 4/3. And then I'm going to kind of box this in so that we have space to see our other ones. Alright, next problem, number 11. Now this one is a little bit more easy because when we look at it, you should immediately notice that it is just 2 fractions, right? 2 fractions set equal. If it's 2 fractions equal, that means we can just cross multiply to solve, which means we don't have to worry about the LCD. However, you should always do the domain. So we have to set our first one equal to 0, so 2x equals 0. So we still have to deal with domain. Divide by 2 means x equals 0 is not allowed, so we can't let x equal 0. Then we take our second one, 2x minus 2 equals 0, and we solve that. So we add 2, 2x equals 2, divide by 2, x equals 1, so x cannot equal 1. So our domain is everything from negative infinity to our smallest number 0, unite it with everything from 0 to our next number 1, unite it with everything from 1 to infinity. So in the end, if we get a 0 or a 1 for an answer, that is not allowed. Now we can go ahead and start cross multiplying. 2x times x is 2x squared. Bring down your equal sign in the middle and then multiply the other way. So 4 times all of 2x minus 2, so we need to put that in parentheses. Now we can go ahead and start solving. 4 times 2 is 8x. 4 times negative 2 is negative 8. Bring down our 2x squared. Now, again, when you look at this, you should notice that there's an x squared and an x. So we're going to have to factor, which means it has to equal 0. So I'm not going to move the 2x squared because then it'll make my lead coefficient negative, and I don't like to deal with that. So I'm just going to subtract the 8x and add the 8. So now none of these are like terms, so I have 2x squared minus 8x plus 8 equals 0. And now I'm going to start factoring by pulling out my GCF. In this case, there is a GCF of 2. So I'm going to divide each one of these by 2 to pull out my GCF. So x squared minus 4x plus 4 equals 0. Now I need to factor my inside, and since my lead coefficient is a 1, we're going to do what multiplies to the last, which is 4, and adds to the middle, negative 4, which would be negative 2 times negative 2. So we have 2x minus 2, x minus 2 equals 0. Set each piece equal to 0, and solve. So x equals 2. X equals 2. Check your domain. Again, 2 is acceptable, so my final answer is just 2, and that answer of 2 just happens to occur twice. All right, on to the last two from this review. When I look at this problem again, we should notice that there's more than 2 fractions, so this is an LCD problem. So we should start out by finding our LCD, which means we need to factor the denominators, and this one factors 2x plus 3, x minus 3, because they're both perfect squares having their differences. No GCF, no squared stays. No GCF, no squared stays. So my LCD for this is x plus 3, x minus 3, and remember that that's the first part of this problem, so it has to be circled as an answer. Again, anytime we're solving an equation, we have to deal with domain. So domain means that the denominator cannot equal 0, so x plus 3 equals 0. Subtract 3 means x cannot equal negative 3. X plus 3, set it equal to 0, and solve. Oh, wait, we already did the plus 3 one. So we have to do the x minus 3 one. So we would x minus 3 means we'd add 3 to both sides, so x cannot equal 3. I already did the x plus 3, I already did the x minus 3, so my domain is everything from negative infinity to negative 3. Unite it with everything from negative 3 to 3. Unite it with everything from 3 to infinity. So now we have our LCD, we have our domain, and now we can go ahead and start solving this problem. So we're going to bring down our first piece, which is 8x plus 21 over x plus 3, x minus 3. And we're going to multiply that by our LCD, x plus 3, x minus 3. Box it in. Bring down our plus sign, 2 over x plus 3, and multiply that by our LCD of x plus 3, x minus 3, and box that one in, equals 5 over x minus 3, and we multiply that by our LCD, x plus 3, x minus 3. Box that one in. Okay, so I'm going to zoom in since I'm writing a little small here, make it easier for you to read. So then we can go ahead and we can cancel out the common factors here. So x plus 3, x minus 3 go away, leaving us with 8x plus 21. Bring down our plus sign. The x plus 3's go away, leaving us with a 2 and an x minus 3. Bring down our equal sign. X minus 3 goes away, leaving us with a 5 and an x plus 3. Now we need to go ahead and solve this. So we need to distribute in to get a positive 2x minus 6. Bring the rest of it down. On the other side, distribute to get 5x plus 15. Combined our like terms. 8 plus 2 gives me 10x. Positive 21 minus 6 gives me plus 15. equals 5x plus 15. Now here, notice that there's not an x squared term. So that means solving this is actually going to be a lot quicker. So first step is I would just move my x's over. So we have 5x plus 15 equals 15. Subtract the 15. 5x equals, now a lot of times people will just say that there is no solution here, but 15 minus 5 is a number and it's 0, and then we can divide by 5 to get x alone, and 0 divided by 5 is 0. Now if we check our domain, the only two values that are not allowed are negative 3 and 3, so 0 is a perfectly acceptable answer for number 12. Okay, and now we're on to our last problem, which is number 13. Again, you should notice that there are 1, 2, 3 fractions, which means we're going to need to have an LCD here. So we need to factor our denominators if we can. Well, x plus 5, no squared, no GCF. X minus 7, no GCF, no squared. This one does have that, so we're going to do what multiplies to the last, which is negative 35, and adds to the middle negative 2. Well, that would be 5 and 7, and my 7 would have to be negative, so this is x plus 5, x minus 7. This goes away, so my LCD has each binomial as part of it, so x plus 5, x minus 7. X plus 5 is already there, and so is the x minus 7, so that is my LCD for number 13. Now don't forget, you can't stop there, you also have to do domain. So domain, we set each piece of the denominator equal to 0 and solve, and then we say that that value is not allowed. So x cannot equal negative 5, and then x minus 7 equals 0, add your 7. That means x cannot equal positive 7 either. So my domain is everything from negative infinity to my smallest number, negative 5. Unite it with negative 5 to 7. Unite it with 7 to infinity. And yes, you are required to tell the LCD and the domain on any problem involving an equal sign that has fractions with variables in the denominator. The equal sign and variables in the denominator means domain is needed. So now we can go ahead and move on to our next piece, which is to bring down each one and multiply by the LCD. So 4 over x plus 5, and we're going to multiply that by our LCD, which was x plus 5, x minus 7. Box that in. Bring down your plus sign, multiply that and the x minus 7, and multiply that by your LCD, x plus 5, x minus 7, box that in, bring down your equal sign and your 18 over x plus 5, x minus 7, and multiply that by your LCD, which is x plus 5, x minus 7, and go ahead and box that one in. Now we can start canceling things out. The x plus 5's cancel, leaving us with 4, x minus 7. Bring down the plus sign. X minus 7's cancel out, leaving us with 6, x plus 5. Bring down your equal sign. X plus 5, x minus 7 cancels out, leaving us with 18. So now we can go ahead and start solving. So we're going to distribute in to get 4x and negative 28 plus 6x plus 30 equals 18. Combine your like terms. 4 and 6 give me 10x. Negative 28 and positive 30 give me a positive 2 equals 18. Again, really nice here. There is no x squared term, so we can just get x alone. So subtract 2. 10x equals 16. Divide by 10. X equals 16 over 10, which would reduce to 8 over 5, and then we can go ahead and check, is this an acceptable answer? The answer is yes, because the only two numbers that are not acceptable here are 7 and negative 5. So 8/5 is your final answer to this problem. All right, make sure you review the steps and remember what to do when so that you're prepared for your quiz tomorrow.